OpenAI just announced an AI that writes, debugs, and reviews code automatically, and 73% of developers in their pilot replaced their junior engineers with it.
Replaced? Are you saying this thing is actually taking developer jobs? So we're breaking down how it works, what it can actually do, and how to position yourself around it?
By minute 4, you'll know exactly whether to embrace it or skill up fast. Let's get into it.
Welcome to the AI Daily Podcast, today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into OpenAI engineering blog.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about OpenAI's Codex and what it really means for the future of software development. This isn't just another AI model release. This represents a fundamental shift in how we think about programming itself.
Right, and what strikes me is how quickly we've gone from AI can generate text to AI can write production code. That's a massive leap in just a few years.
Exactly. When you look at the trajectory, it's remarkable. We went from GPT-2 in 2019, which could barely string together coherent paragraphs, to Codex, powering GitHub Copilot, and fundamentally changing how millions of developers write code every day. The adoption curve has been unlike anything I've seen in developer tools.
The numbers are staggering. GitHub reported that Copilot is now generating about 46% of code in files where it's active. That's nearly half of all code being AI-assisted.
And that's where this gets really interesting from a platform engineering perspective. We're not talking about simple autocomplete anymore. Codex understands context across entire code bases, can translate between programming languages, and even comprehend natural language descriptions of what you want to build.
But here's what I'm wondering. Is this actually making developers more productive, or is it creating a new kind of technical debt? I've seen some pretty questionable code come out of these systems.
That's the key question, isn't it? The data suggests it's both. Microsoft's own studies show developers using Copilot complete tasks 55% faster. But you're right, there's a quality question. A recent GitClear study found that AI-assisted code tends to have more churn, meaning it gets rewritten more often.
Which makes sense. If you're accepting suggestions without fully understanding them, you're essentially copy-pasting from Stack Overflow on steroids.
Precisely. And this brings us to the bigger picture, the competitive landscape. OpenAI isn't alone here. Google's got their coding tools, Anthropic's Claude is surprisingly good at code, and there are startups like Replit and Cursor building entire IDEs around AI.
It feels like we're in an arms race. Everyone's trying to own the developer workflow.
Because whoever owns the developer workflow potentially controls the future of software creation itself. Think about it. If every developer becomes dependent on your AI assistant, you're essentially setting the standards for how code gets written.
And the implications go way beyond just productivity metrics. We're talking about fundamentally changing what skills a developer needs.
Exactly. The traditional path of learning syntax, memorizing APIs, understanding low-level implementation details, that might become less relevant. Instead, we might need developers who are better at describing problems, reviewing AI-generated code, and understanding system architecture at a higher level.
Which raises some uncomfortable questions about junior developers. How do you learn to review code if you've never written it from scratch?
Coming up, we'll dig into exactly how OpenAI pulled this off technically, what makes Codex different from just fine-tuning GPT-3 on code, and why some of the benchmarks might be misleading us about its real capabilities.
So let's get into the technical meat of how Codex actually works. It's not just GPT-3 trained on GitHub, right?
No, and that's a common misconception. While Codex is built on GPT-3's architecture, OpenAI did some clever things. First, they trained on 159 gigabytes of Python code from public repositories. But here's the kicker. They didn't just dump code in. They carefully filtered for quality, removing auto-generated files, looking at star counts, and focusing on well-documented code bases.
The code training curation is fascinating. They essentially created a corpus of good code practices.
Right. And then they did something even smarter. They fine-tuned specifically on code completion tasks, not just next token prediction. The model learned the patterns of how developers actually write code, starting functions, completing logic blocks, handling edge cases.
What about the benchmarks? I've seen claims that Codex solves 70% of programming problems, but that seems optimistic?
You're right to be skeptical. The human eval benchmark that everyone cites, where Codex achieves about 70% success, consists of relatively simple, self-contained programming problems. We're talking about functions that reverse strings or calculate Fibonacci numbers. Real-world programming is much messier.
Much messier. You've got legacy code bases, complex dependencies, business logic that spans multiple services.
Exactly. And that's where the real-world performance data gets interesting. When you look at actual usage in GitHub Copilot, the acceptance rate for suggestions hovers around 30%. That means developers reject 70% of what it suggests. But here's the nuance. That 30% that gets accepted tends to be the boring, boilerplate stuff that developers hate writing anyway.
So it's like having a really eager junior developer who's great at writing test fixtures and CRUD operations but needs supervision for anything complex.
That's a perfect analogy, and it explains why the productivity gains are real, but not revolutionary. Studies from Microsoft show that developers feel more productive and enjoy their work more when using Copilot, but the actual code velocity improvements are modest, around 20 to 30% in controlled studies.
But there are some serious gotchas, right? I've heard about security issues with AI-generated code.
Oh, absolutely. A Stanford study found that developers using AI assistants wrote significantly less secure code. They were more likely to include SQL injection vulnerabilities, use weak cryptographic practices, and trust user input without validation. The AI learned from public code, which includes plenty of bad examples.
And what about licensing? If Codex trained on GPL code, does that mean my proprietary software might accidentally include copyleft code?
That's the million-dollar question that's still being litigated. GitHub argues that Codex's suggestions are transformative and don't constitute copying, but there have been cases where it's reproduced verbatim code blocks from training data, comments and all. OpenAI's added filters to reduce this, but it's not perfect.
So how does this compare to the competition? Is Codex really that much better than what Google or Anthropic are doing?
The landscapes evolved rapidly. Codex had first-mover advantage with GitHub integration, but technically the gaps are closing. Google's internal models that power their IDE features are reportedly on par. Anthropic's Claude is particularly interesting because it's better at explaining its reasoning, which matters for code review scenarios.
And then there are the specialized players like Cursor and Replit that are building entire development environments around AI, not just code completion.
Which brings us to the real disruption. It's not about who has the best model, it's about who builds the best integrated experience. Cursor, for example, lets you chat with your entire codebase, asking questions like, where is user authentication handled? That's a different paradigm than just autocomplete.
But this all assumes the models keep improving. What if we've hit a plateau?
That's a critical point. The jump from GPT-3 to GPT-4 in coding ability was substantial. Better at following complex instructions, understanding context across files, even debugging its own code. But the improvements are becoming incremental. We might be approaching the limits of what pure language modeling can do for code.
Which might explain why everyone's pivoting to agent-based systems, having AI that can actually run code, see errors, and iterate.
Exactly. The future isn't just about generating code, it's about AI that can test, debug, deploy, and monitor. Stick around. We'll dive into what this means practically for your team and what you should actually do about it. So, given everything we've discussed, what should platform engineering teams actually do about this AI coding revolution?
First, let's be practical. If you're not already piloting AI coding tools, you're falling behind. But, and this is crucial, you need a thoughtful adoption strategy. Don't just throw Copilot licenses at everyone and hope for the best.
Right, because we've seen what happens with unmanaged adoption. Shadow IT, but for code generation. Exactly. Here's my recommended approach. Start with a small pilot group. ideally your most experienced developers. They have the judgment to evaluate suggestions properly. Track metrics that matter, not just velocity, but code quality indicators like bug rates, security vulnerabilities, and long-term maintenance burden.
What specific metrics should teams focus on?
Look at code review turnaround time. Are AI-assisted PRs taking longer to review? Monitor your test coverage. Developers using AI tools sometimes skip tests because the AI doesn't suggest them. Track security scan results before and after adoption. And here's one most teams miss. Survey developer satisfaction monthly. The productivity gains mean nothing if your team burns out from constantly fixing AI-generated bugs.
What about establishing guidelines? I've seen teams struggle with when to use AI and when not to.
Critical point. You need explicit policies. Here's what works. AI for boilerplate and well-established patterns? Yes. AI for security-critical code, authentication logic, or cryptography? Absolutely not. AI for test generation? Yes, but with human review. AI for architectural decisions? Never.
That makes sense. Use it as a productivity tool, not a decision-making tool.
Precisely. And train your developers on prompt engineering. The difference between a vague request and a well-structured prompt is massive. Teach developers to provide context, specify constraints, and always review generated code as if they're reviewing a junior developer's PR.
What about the longer-term strategic considerations?
This is where it gets interesting. You need to rethink your hiring and training strategies. The skills that matter are shifting. System design, code review, understanding business requirements. These become more valuable. Memorizing syntax and APIs, less so. Consider creating new roles like AI code review specialist or having dedicated team members who become experts at working with AI tools.
And from an architecture standpoint, this might actually push us toward better practices, right? Cleaner interfaces, better documentation?
Absolutely. AI coding tools work best with well-structured, documented code bases. This creates a virtuous cycle. Teams that adopt AI tools are incentivized to improve their code quality, which makes the AI tools more effective. I've seen teams refactor legacy code just to make it more AI-friendly, and the code ends up better for humans, too.
But what about the risks we discussed, the security vulnerabilities, the potential licensing issues?
You need technical controls. Set up pre-commit hooks that scan for common AI-generated vulnerabilities. Use tools like GitHub's Copilot filter to reduce verbatim code reproduction. Most importantly, invest in security training that specifically addresses AI-assisted coding risks. Your developers need to understand that AI suggestions might include outdated or insecure patterns.
What should teams watch for in the next 12 to 18 months?
3 things. First, agent-based systems that can actually run and test code. These will be game changers. Second, specialized models for specific frameworks or languages. We'll see React Copilot or Kubernetes Assistant that deeply understands specific ecosystems. Third, integration with other parts of the development lifecycle. AI that can update documentation, generate deployment configs, even suggest architectural improvements.
It sounds like the key is staying adaptive. This space is moving so fast.
That's exactly right. And here's my final thought. This isn't about AI replacing developers. It's about amplifying human creativity and judgment. The developers who thrive will be those who learn to conduct the AI orchestra, not those who try to compete with it on writing for loops.
It reminds me of how IDEs transform development. Nobody argues we should go back to plain text editors, even though IDEs abstract away some fundamental skills.
Perfect comparison. And just like IDEs, AI coding tools will become invisible infrastructure. The question isn't whether to adopt them, it's how to adopt them thoughtfully, safely, and in a way that enhances your team's capabilities rather than creating dependencies you don't understand.
The future of development isn't AI or humans. It's AI and humans working together in ways we're just beginning to explore.
And that future is being written right now, one AI-assisted commit at a time. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating shift happening in enterprise software development. Harness is making the case that resilience testing isn't just nice to have anymore, it's absolutely critical. They're introducing this concept of resilience debt that builds up when companies skip proper testing.
Resilience debt? That's an interesting way to frame it. So basically, every time you push code without chaos engineering or proper failure testing, you're accumulating technical debt that could blow up later.
Exactly, and they're advocating for making it a continuous practice throughout the entire SDLC, not just something you tack on at the end. Speaking of continuous improvement, Together AI just announced a major expansion to their fine-tuning service.
Oh, this is big. They're adding native support for tool calling, reasoning, and vision language models. And get this, they now support models up to 1 trillion parameters.
That's massive scale. This could really democratize advanced AI capabilities for companies that want to customize models for specific use cases. Meanwhile, Red Hat is making moves to unlock more value from their container images.
Right. They're showing developers how to leverage no-cost Red Hat developer subscriptions to access the full RHEL container ecosystem. It's smart. Lower the barrier to entry, get more developers building on your platform.
Now, here's an interesting pivot. Walmart and OpenAI are reportedly shaking up their AI shopping partnership. According to Wired, the instant checkout feature in ChatGPT hasn't been delivering the sales they expected.
Not surprising, honestly. Shopping through a chatbot interface still feels awkward for most people. So what's Walmart doing instead?
They're doubling down on their own Sparky chatbot and focusing on embedding AI more naturally into their existing shopping experience. Sometimes the flashy partnership isn't the right solution.
Speaking of partnerships and open source, there's been some buzz on X about big tech supposedly abandoning open source, though I should note the actual content seems to be blocked by some technical issue on X's platform.
Yeah, the irony isn't lost on me. A post about open source being inaccessible due to JavaScript requirements. But it does touch on a real trend we're seeing with some major tech companies becoming more protective of their AI models.
While others, like the author of that post, are apparently doubling down on open source. It's becoming a real philosophical divide in the industry.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.